Visit Chandra's beautiful universe. Hot Jupiters. Planets can force their host stars to act younger than their age, according to a new study of multiple systems using NASA's Chandra X-ray Observatory. This may be the best evidence to date that some planets apparently slow down the aging process for their host stars. While the anti-aging property of hot Jupiters, that is, gas giant exoplanets that orbit a star at Mercury's distance or closer, has been seen before, this result is the first time it has been systematically documented, providing the strongest test yet of this exotic phenomenon. A hot Jupiter can potentially influence its host star by tidal forces, causing the star to spin more quickly than if it did not have such a planet. This more rapid rotation can make the host star more active and produce more X-rays, signs that are generally associated with stellar youth. As with humans, however, there are many factors that can determine a star's vitality. All stars will slow their rotation and activity and undergo fewer outbursts as they age. Because it is challenging to precisely determine the ages of most stars, it has been difficult for astronomers to identify whether a star is unusually active because it is being affected by a close-in planet making it act younger than it really is, or because it is actually young. The new Chandra study approached this problem by looking at double star, or binary systems, where the stars are widely separated, but only one of them has a hot Jupiter orbiting it. Astronomers know that just like human twins, the stars in binary systems form at the same time. The separation between the stars is much too large for them to influence each other, or for the hot Jupiter to affect the other star. This means the astronomers conducting the study could use the planet-free star in the system as a control subject. The team used the amount of X-rays to determine how young a star is acting. They looked for evidence of planet-to-star influence by studying almost 36 systems in X-rays with Chandra, ESA's XMM Newton, or both. They found that the stars with hot Jupiters tended to be brighter in X-rays, and therefore more active than their companion stars without hot Jupiters. While previous studies hinted at this effect, the latest research is the first where astronomers found statistical evidence that some planets are influencing and keeping these stars acting young. The hope is that future studies will help uncover more systems to better understand this effect.